Continuing now with example 5. There have been 43 presidents of the United States. Their mean height is 70.8 inches with a standard deviation of 2.7 inches. Explain why these data should not be used to construct a confidence interval for the mean heights of presidents. Well, this gets to a fundamental issue with confidence intervals. So when you look back at confidence intervals, section 9.1, section 9.2, doesn't matter. What we're talking about is not knowing where the real mu is. You're building a confidence interval for the population mean mu because you don't know what it actually is because you only have a sample. So you have to take your sample value, which is x bar, and build an interval from it. But if we look at the problem that they're talking about here, it's about the presidents of the United States, and we know exactly how many of them there have been and how tall they all were, which means we're not actually going to need a confidence interval because we actually know what mu already is. We know that mu is 70.8 inches, and there's no need to build an interval for it because we don't have a random sample taken. If there was a random sample of presidents, then I could build an interval. But since I have all 43 presidents, I would not make a confidence interval there. There. I know the mu is 70.8, and so that would mean that there is no need to make an interval. All right, so that was just a little logic question. So now let's do one last problem. We have the U.S. Department of Health and Human Services reported the results from a study in 2008 of 100 random sickle cell anemia patients. It was found that their mean length of hospital stays was 7.2 days. The standard error of the mean was 0.53 days. You want to construct a 98% confidence interval for the mean length of stay for sickle cell anemia patients. All right, so we're going to start by finding all the following values that they want. So the first thing we're looking for is the sample size. So right here it says 100 random sickle cell anemia patients. So that would be our sample size. N is 100. Make this smaller so that way it's easier to see. All right, now if N is 100, your degrees of freedom would be N minus 1, right? So degrees of freedom is N minus 1. And that would be 99. There we have it. All right, next, the sample mean. Well, the sample mean comes from our data set, so let's see here. Oh, the mean length of their stay was 7.2 days. There it is right there. So the mean length of stay was 7.2. So that means that x bar is equal to 7.2. And I'll highlight that in yellow so we can see it. Now the confidence level they would like is 98%. So we have a 98% confidence level right here. Okay, so that would be the C level. Pretty straightforward. And that means that alpha, it remembers the complement of your confidence level. So that means that alpha is 0.02 because it's 1 here, 1 minus 0.98, which is 0.02. Again, complement rule from chapter 5. So it's the complement of your confidence level. All right, last but not least, S sub x bar. So we learned this notation in chapter 8.1, although it was sigma at the time because we knew the whole population. But we currently don't know the whole population. So that's S sub x bar, which is from section 8.1. It was the standard error of x bar. And then it was actually given to us right here. It says the standard error of the mean was 0.53 days. So there's that. So we know that SE of x bar, which is that formula, is equal to 0.53. But technically we don't have to put the formula in there, but I just wanted to remind you because it's been a while since you've seen it. And you're going to need it in a minute. All right, so we know all of our values. Right here, that one was given to us. Now the next thing they want is for us to compute the standard deviation of the mean length of stay. And that's where we're going to need this formula for the standard error of x bar. So let me use this formula. All right, so I know that the standard error is 0.53 because it's given to me in the problem. And I know that should be approximately equal to s, which is what I'm looking for, divided by the square root of n, my sample size. Except I know that my sample size is 100. I found it right up there. Okay, so this is 0.53 is approximately s over 10, because the square root of 100 is 10. So to solve this, all I need to do is multiply both sides by 10. Because over here on the right-hand side, 10 divided by 10 will divide away to 1. In other words, it will cancel. And then I'm going to do it over here to the other side, because I can. And multiply that by 10. So I grab the calculator. 10 times 0.53 would be 5.3, of course, because the decimal will move one spot over when you multiply by a 10 or a product of 10. All right, so we have that s is approximately 5.3. Better give that a box. Makes it really obvious. All right, so now we need to construct a confidence interval for the mean length of stay using the calculator. All right, so whenever they say that, it always helps to put in what calculator entry you're using. So let me remind you that we're looking at this formula right here, so we're going to use the t interval. So let's put down that we're going to use the t interval. Okay, so let's grab the calculator. I need these items. All right, so I'm going to go to Stat and Tests. And we want number 8, if you recall, down here, t interval. You can press down several times and then hit 8, but you could also just press 8. All right, now this time we're going to have stats because we don't actually have the actual data from this problem. So we have stats. Our mean was 72. I think. Let me double check that. 7.2, excuse me. 7.2, because this is the mean length of a hospital stay. Right. If you say 72 days, we've got problems. So 7.2. Now the S is the standard deviation, and that's the number we just found. It's not the pink number up here. That's the standard error. It's the 5.3 we just found here. So I'm going to grab that, 5.3. N was 100, and I want a 98% confidence level. And I press enter and calculate. And there's our answer right there, 5.9468 and 8.4532. And then I just typed that up and put it right in there. All right, now what was the point estimate and the margin of error for the average of length of stay using the interval? Now we actually know what the point estimate was. It was 7.2, but just a little reminder of how to do this. So let me enter a box here 1 second. All right, so just a reminder that the point estimate is the center of our interval. So what we need to do is since we need to use the interval to find this value, we need to add up the two numbers we have and divide by 2. So x bar will be equal to, and then let me find these two numbers again, 5.9468 plus 8.4532 divided by 2, which will be 7.2. I'm just going to say it. Let me go prove it. So I had 5.9468 plus 8.4532. I add them up, then I divide by 2, and lo and behold, I get 7.2. Now, let me go back. There we go. So there's the point estimate. Done. Now we need the margin of error. But the margin of error is the distance, or is half the distance from one end to the other of the interval. So what that would be take the difference between the two numbers and divide that by 2. There, and I just typed that up. So it's the high number, 8.4532, minus the low number, 5.9468. You need to subtract them and divide by 2, because that'll get you your distance from your edges to your mean, to your center in the middle, which is your sample mean. So 8.4532 minus 5.9468, divide that by 2, and I get 1.2532. And there you go. That's how to find your margin of error from your width of your interval. And since it said to use the interval to do that, we did that. Now, suppose a hospital chief claims that patients, the majority, there's an interesting word, the majority of sickle cell anemia patients take less than 9 days to recover. There we go. Less than 9 days to recover. Does this confidence interval support or contradict their claim? Okay, so less than 9 days. Look at the interval we have right here. So if we look at this interval, we can see that it's basically below, I'm just making a color, it's below 9 period, right? The highest number there is below 9. So the claim is that the mean is, or mu, I guess I should say, the mu, the population mean, is less than 9. So their claim is that the mean length of stay is less than 9. And our interval supports that claim because our entire interval is below 9. Even the highest number in that interval is below 9. If they had claimed more than 9, then we would have contradicted them with our interval. All right, we're all done with section 9.2. I'll see you back here for 9.3.